Hello friends, before we begin today's video, just a recap on what we discussed in the last video. We discussed about the complete layout plan for the Toporama Marklin mini club layout, and we discussed about the salient features of those layout, some of it like building a moving car system, magnetic moving car system using 3D printing technology, and followed by that we will be implementing track control system and signal control system using Arduino based microcontroller, and after that we will be converting the layout to DCC layout in which the locomotives will be having a decoder, which is a small footprint decoder. And last but not the least, we will also be 3D printing some of the buildings that is required for this layout, as well as the pantograph system. So moving on to the next section, which is the today's topic, which is the magnetic rail system. As you can see from behind me, some sort of road section has been built already. So I'll be going through the complete making of this particular road section. If you see this road, the road landscape in this layout is based on the Toporama landscape, which was introduced in 1975 as a layout mat, landscape mat, the product number 8930. This is a plain and simple mat. It costs around 200 euros in the market, and it goes under hammer immediately as soon as it comes into any auction. So one of the rare collectibles. But here we are not going to go over go after the mat and purchase it, but instead we are going to replicate it actually. So to replicate, what I have done is basically I have compared it based on the approximate position of the buildings and the track plan. Once the buildings were placed and the tracks were placed, it was quite easy to trace out the road sections, which by far it's not accurate, but still more or less to what the layout demands. So let's go into making this. Okay. To start with the magnetic rail system, these are the basic components that you need for this. First is this motor mounting system, which is designed and printed in 3D, and there are a couple of gears. These gears which are placed between these two mounts like this. You will be needing two O-rings like this, or what you call it as a gasket. The dimension and where to get this particular gasket or this washer. This is the main thing that actually fits into this gear like this, and then this part here like this, and then they both, when they rotate the track, the chain is pushed through it actually as we speak, pushed through it, and they create the friction to make the wheels move. So this is like after fixing the washer inside there. So one has got a bigger diameter which gets into this right side of the gear wheel, and the other one has got a smaller hole through which the motor is actually mounted. The motor is basically a 12-volt motor, a DC motor, and it should ideally have a low RPM, and so this motor has got a 4 mm shaft which smoothly fits into this gear mount. So I've just placed it somewhere in between, so that when the chain drives, it just takes in the load evenly. To control the motor, we have basically this powering unit, which I purchased again locally here online. I'll share the link. It is basically a 12-volt motor drive with the on-off switch and regulator, speed regulator. So since I was able to get only 100 RPM, which ideally is not recommended, or we require a much lower RPM motor, say around 35 or 40 RPM motor. Since I didn't get that exact speed, I thought I will regulate the speed of the motor using this potentiometer, which is part of this controlling circuit. So that's about the main heart of the system. The remaining is all about laying the track, and there is a chain system which I will explain now. So this is basically the rails actually. This rail is also designed and printed in 3D. So these are actually printed in ABS material. All these 3D printing elements are actually printed in ABS. You can also print it in PLA, but PLA is having a lesser strength, so I prefer to print it in ABS. And it is quite a time consuming process. Probably I'll make another video to show how you simply do a small design and print out and realize what you designed into a physical piece. So what actually happens is that here I have every track. Basically this is one piece of track, so it keeps getting you get another piece like this, and then you just all you have to do is just snap it together like this, and it fits together and creates that length for you. So you can just keep on adding like this. How you integrate it with the center gear movement part is, you just snap it from the bottom here, there it goes, like that the other side also. So it's just fitted here, and then I'm just doing it the other side, so like that it snaps, and then you've got to just mount it here like this, and then start laying the screws here. There is a provision I provided to mount the screws through which you can drill a hole and then mount it permanently. So what happens next is the very important part. This is basically the one small unit of the chain actually. So I hope that is visible. Yeah. So this is another part. Like you've got to print quite a few of them, and then you have to see how much you're having to cover the entire layout actually. So what happens is this actually snaps together like this, and then it forms a link. Sorry, this is the chain that is actually made one after the other, and usually the whole track, when it's built, it is placed like this somewhere, and then this gear mechanism basically moves it like this to push it forward like that. Yeah, so this is the center part of it. The same thing repeats to the entire chain. Only thing is, if you see the corner here, the corner, basically this is where the vehicles take a turn. So this is a very important aspect. So for that there is a solution where this particular turnarounds are designed, and this is basically the turnaround which is here, and what happens is a turnaround and a supporting wheel to it, and we actually place the wheel inside like this, and then place it here where the vehicle has to take a turn, and the chain basically moves around through this without creating any friction, or it passes through seamlessly. So that's how it will work together like this. So that is the funda behind the moving car system. So now what I'm going to do now is, I'm going to since this motor is basically going to get mounted, it will be like something like, it will come at the bottom of the gear system. So we have to mount it like this through this. So which means I need to make a hole to accommodate this portion and this portion. And I'll also explain the dimensions in terms of what is the height we have to maintain and all. There are generally recommendations in internet to do a routing to create a depth of to the level of this chains here, and then just put it underneath to the board level. That I'm not going to do. That's a heavy task. Routing the entire table also might cause it to wobble or weaken the board. Even otherwise, if I have to route to a level of 8 mm or 6 mm, I need to get a bigger board or thicker board, which is going to increase the weight of my layout overall. So I didn't want to do that. Instead, I will put the entire chain mechanism on the flat surface of the board, and then to its height I will raise the entire rest of the surface of the layout to mount the tracks and other things like that, so that goes into the depth. But nevertheless I need to make a hole to provision the motor of course, which is going to go to the bottom of the board actually. So after I mount it, I'll come back again and then I'll show you how it is all done. And I'm also going to place the track, basically this rail tracks actually, to this entire path, and then screw it up, and then we will meet again and see how things turn out. Thank you all. Okay, I want to show you how the chain or the moving part, main chain part is built actually. So I did face some challenges while making it. So initially when I printed in 3D, if you can, so let me see if I can get it close to you. If you can see, it is basically having a small peg and also a hole the other side, hole on the other side actually. But this had a problem actually. This basically had a problem when I tried to make the peg actually. So uh, it was joining, no issue in that, but only thing is it did not hold on to the strength actually. It was like snapping out like this very easily. See, as you can see, it just broke. It just broke. So it was not strong enough to hold the chain. So before even testing it, I decided to discard this idea of putting a peg and then joining them like a chain. So I made changes in the design of the carriage to accommodate basically a thin wire between them, so that when the carriage sits on the track, then the wire doesn't protrude, so it sits inside within this gap. Actually, there is a 2 mm gap provided here, right here. So through that it sits. So I just slipped the cable. This is a 24 AWG cable. So I just pass through this like this, and then it's just like making a chain out of pearls. There is a hole here and here, so I just pass this and just pull it together, then it just sits inside. The wire just sits inside and doesn't come out. It's flush actually. It's wire just doesn't sit inside, and it is just flush. And then I make a knot on top of this peg here like this. I don't know if you all can see it clearly. So I make a knot like this, and then on top of that I just put a dab of Fevikwik or Sino bond, and that really holds it together. And then I cut off the wires. So this is how I form the chain actually, and it moves actually to a decent angle of 30 to 45 degrees. If it moves, then it can cover the track actually in a very smooth manner. So this is how I made the chain. It took quite long time in the sense like nearly about 6 hours to make a 8 feet chain actually. So this is one of the major work actually, time consuming work in this particular magnetic rail system. And after making this actually, let me just cut that so that I can tell you what's the next step that I did. Okay, after making this chains like this, then I have to use the magnets. So I used a 3x3 cylindrical magnets in a 3x3 cubical space. First I thought of getting a 3x3 cubical magnet, but it is not available in India. So I used a 3x3 cylindrical magnet as like this. Yeah, so this is the magnet that is running on the chain actually. Moving vehicles actually is having two parts actually, the vehicle itself and also this very important part called the slider actually. This is a slider. Okay, so this slider is something that accommodates a magnet which gets attached to the vehicle. So I made two types, one for the small vehicles like two-wheelers or the Z scale. Another one is a bigger a slider for HO scale vehicles. So this slider was actually made using a laser cut from a brass sheet like this. So this was a full sheet, a 0.5 mm thickness sheet, and this design was made in CAD and given for laser cutting, and we were able to make these sliders actually. So one of this particular slider has got a gap of around this slider has got a gap of around 5 mm if you see here. Just for this I'm using a different size magnet. That's a 2 mm magnet. This 2 mm magnet is placed on the slider like this. I don't know how much of this is visible in the camera, like this, and then fixed with an arrow lid, like this, 2 magnets here. And similarly on the track also you will get 2 magnets adjacent to each other, and when you are actually doing it, you need to be careful to check the polarity of the magnet, otherwise the vehicles will not stick to each other in the track. So what we do that, how we do that is basically like assuming that there is a magnet over here. What I will do is, like, I'll place the slider on top of this, something like this, and then on top of that I'll just put a magnet. It sticks wherever it is. Now I know that this sticks there, and this is the polarity of this magnet. This is the polarity of this magnet, and then I just mark the top of that pole of the magnet using a permanent marker to ensure that that goes to the exposure area, and the bottom one gets stuck to the slider actually. So that's the way I figured out to put it. Otherwise the vehicles won't stick to each other to run. One slider here, if you can see it. This vehicle has got this, also an N-scale car. So this one has got again a similar slider, 5 mm slider attached to it. And there are options for vehicles actually. So okay, just to cover on the vehicles that can be used on this is it's got a huge variety. It can cover starting from 1:300 scale small scale cars like this, which are 3D printed, or even this cheap Chinese ones actually. They are also available over the internet actually. If you want, like, you can go and purchase in Amazon, and or even you can run the premium cars. These are from Notch actually. It's little on the higher cost, and this is a Tommy Tech scooter in 1:160 scale actually. And these are HO scale cars also, which can be run on this, including a bus in HO scale also can be made to run on this magnetic scale. So that's about it. And I have just painted a portion of my layout, and the remaining I'm just keeping it open to troubleshoot if there is any issues that's going to upcoming. And I will finalize the decorations on the road platforms and other trees and all only at the very fag end. And the next video session we will be covering mainly on our main track laying, as well as implementing the track control and signal control using Arduino, which is going to be even again very interesting. So that's about it from now. Thank you all. Thanks for joining.